Hi dear students, this class I am going to discuss how to find out the area of an oblique ellipse. You know how to find out the area of an ellipse. X square by a square plus y square by b square is equals to 1, whose semi-major axis is a and the semi-minor axis is equals to b. The area of this ellipse is given by pi ab. You know this particular idea. Now the ellipse is an oblique ellipse. This is the ellipse, or we can say the ellipse equation is in this form. 17x square plus 12xy plus 8y square is equals to 20. It is an oblique ellipse. So for that what we are doing is, so from center of the ellipse, so this distance is equals to r and this angle is equals to theta. That means any point on the ellipse is of the form r cos theta comma r sin theta is a point on the ellipse. So the maximum value of r, is the length of the semi-major axis and the minimum value of r is the length of semi-minor axis. That is the idea we are going to use. If you know the length of the semi-major axis and if you know the length of the semi-minor axis, then we can use the formula for this finding the area. So that's why x is equal to r cos theta and y is equal to r sin theta. I substituted in this ellipse equation. Then we got the value of r square is equal to this one we got. I converted the equation in the form of a cos theta plus b sin theta plus c form. Okay, r square is equal to, this is the information we got. Here I written cos square theta is equal to 1 plus cos 2 theta divided by 2. 2 sin theta cos theta can be written as sin 2 theta and sin square theta can be written as 1 minus cos 2 theta divided by 2. So by all that simplification I got r square is equal to 40 by 9 cos 2 theta plus 12 sin 2 theta plus 25. Everyone know a cos theta plus b sin theta plus c. This expression maximum and minimum values are c plus r minus root of a square plus b square. That's why we got the maximum value as 40, minimum value as 10 for the denominator. But we have to find out the maximum value of r square. To get the maximum value of r square, denominator must be minimum. Minimum value of the denominator is 10. At the same time, to get the minimum value of r square, denominator must be maximum, that is 40. So that's why we got the value of b square is equals to 1. That's why b value is equals to 1. And we got the value of a square is equal to 4. That means a value is equals to 2. That's what I told. The maximum value of r is the length of the semi-major axis. And the minimum value of r is the length of the semi-minor axis. So a value, b value we got. Then the area of this oblique ellipse is given by pi ab, that is nothing but 2 pi. Hi dear students, the another method I am going to discuss how to find out the area of an oblique ellipse. So the equation is given as 5x square plus 6xy plus 2y square plus 7x plus 6y plus 6. So compared to the earlier question, because whether you observed or not, in the earlier question x square term is there, xy term is there, y square term also there, because we are taking x is equal to r cos theta, y is equal to r sin theta, then cos square theta, sin 2 theta, sin square theta. Cos square theta can be written as 1 plus cos 2 theta by 2, sin square theta can be written as 1 minus cos 2 theta by 2. Then but here sin theta cos theta terms. That's why getting the maximum and minimum values of r square is going to be difficult there. That's why this method we can apply for the earlier problem also. So what we are going to do here, this is the given curve equation. The given curve I converted into a quadratic equation in y. In the y square term, next y term and next constant term we are treating this one, right? So it is a quadratic equation in terms of y. Now I am finding y is equal to minus b plus r minus square root of b square minus 4ac divided by 2a. Now from this we got y is equals to this one. After simplification we got. Okay, let us say this is u and this one as v. So we got u plus r minus v divided by 2. So what the information we got? Y is equal to u plus v by 2 with a plus one equation. with the minus we got another equation, y is equal to u minus v by 2. So these are the two curves, just you can observe here. So y square is equals to x square. This is the combined equation of pair of straight lines passing through origin. Two lines combined equation, that one, y square minus x square is equal to 0. One equation is y is equal to x, the other equation is y is equal to minus x. These two combination, these two multiplication, we are getting the equation y square minus x square is equal to 0, combined equation of the pair of straight lines. Like that, y is equal to u plus v by 2 is one curve, and y is equal to u minus v by 2 is another curve. These two curves combination, we are getting that oblique ellipse. So this part is, say, let us say y is equal to u plus v by 2, and the bottom part is, say, y is equal to u minus v by 2. But where these two curves are intersecting, this point of intersection required. To find these two point of intersections, we have to solve these two equations. Y is equal to u plus v by 2, y is equal to u minus v by 2, we are solving. That's why u plus v by 2 is equal to u minus v by 2. From there we got v is equal to 0. Or v is nothing but this must be equal to 0. If this is, because this is v. If this is equal to 0 means you will get root of x minus 1 into root of 3 minus x is equal to 0. We are getting x value is equals to 1 and x value is equal to 3. So that's why this point we got 1 comma 0 and this point we got 3 comma 0. So now we have to find out this entire area, we have to find out. In this portion, x values are changing from where to where? X values are changing from 1 to 3, upper curve minus lower curve. The upper curve minus lower curve, you will get the area bounded between these two curves. That's why x values are changing from 1 to 3, upper curve minus lower curve, that is nothing but v. V is nothing but root over x minus 1 into 3 minus x, right? So that's why integral 1 to 3 root of x minus 1 into 3 minus x dx. But what about this integral value? I hope so everyone know, which we discussed in the earlier class. This answer, that means integral a to b square root of x minus a into b minus x dx. The earlier class we discussed, we can write this one as pi by 8 into b minus a whole square directly. So that's why this answer becomes pi by 8 into b minus a whole square, that is nothing but 3 minus 1 whole square, you will get 4. So the area we are getting it as pi by 2. The area bounded by an oblique ellipse is given by pi by 2. This method we can use for the earlier question also. This is the general method where we can use. Here you are using r cos theta and r sin theta, means getting the maximum and minimum values is going to be difficult. That is the reason this problem, this method we can follow for every oblique ellipse. Okay, bye.